Dear students, now I want to discuss. This is the first lecture from some basic concepts of chemistry. So today I want to discuss very few topics in this lecture. Importance of chemistry, matter, classification of matter, and base physical quantities. So first, importance of chemistry. So nowadays chemistry play a major role in science. So first one, biological purpose. Biological purpose. So biological purpose, chemistry play major role. The best compound, nitric oxide. Nitric oxide. Its chemical formula NO is act as messenger compound. Is act as messenger compound. Is act as messenger compound. Messenger compound means it can transmitted. It can transmit. It can transmit signals from brain to nervous system, vice versa. This is one important application. So nitric oxide act as messenger compound. That means it can transmit signals from brains to nervous system to brain, vice versa. And this nitric oxide, this chemical is also slow down the growth of tumor cells in human body. So these are the importances of nitric oxide. These are the two main importances of nitric oxide. So it acts as a messenger compound and it can also slow down the growth of tumor cells. This is biological purpose. Now coming to second importance, life-saving drugs. Life-saving drugs. So cisplatin and taxol. These two chemicals are used as drugs for cancer therapy. These are used to cancer therapy. Cancer therapy. And another chemical, that is AZT. It is also known as azidothiamidine. Azidothiamidine. It is used for AIDS victims, AIDS patients. This chemical is used for AIDS patients. This is the reason cisplatin and taxol and AZT, these three chemicals are called life-saving drugs. So cisplatin and taxol used for cancer therapy and AZT used for AIDS victims, AIDS patients. And here cisplatin structure. So structure of cisplatin. You know, platinum to ammonia ligands and to chlorine ligands to ammonia ligands to chlorine ligands. Here either two chlorine ligands or two ammonia ligands are on same side of the same side or same plane. So either two chlorine atoms or two ammonia ligands are in same plane. So two chlorine atoms or two ammonia are in same plane. So this is the cisplatin, same side. Okay, so cisplatin. This is cisplatin. Only cisplatin is used for cancer therapy, not transplatin. This isomer only having that characteristic. Next one, third one. In crop industry, means uh, in agricultural industry, so in agricultural industry nowadays are using NPK fertilizers. NPK fertilizers. NPK fertilizers. You know, N means nitrogen, P means phosphorus, K means potassium. NPK fertilizers. So nitrogen, potassium, phosphorus, relevant chemicals as used as fertilizers. These are used to grow up the plants and giving good productivity. So best example, urea, and its chemical formula NH2, C double bond O, NH2. Now fourth one, insecticides and pesticides. Insecticides and pesticides. You know, DDT is the best insecticide. DDT is the best insecticide. So it is used to kill the microorganisms and grow up the plants and giving good productivity. DDT full form dichloro diphenyl trichloroethane. So dichlorodiphenyl trichloroethane, and its structure so this is the DDT. So dichlorodiphenyl trichloroethane. And chemistry has helped in stabilizing industries which manufacture utility goods like acids, alkalis, dyes, polymers, metals, etc. These industries contribute in a big way to the economy of a nation and generate employment. And also in recent years, chemistry has helped in dealing with some of the pressing aspects of environmental degradation with a fair degree of success. Safer alternative to environmentally hazardous refrigerants like chlorofluorocarbons, responsible for ozone depletion in the stratosphere, have been successfully synthesized. So here, food preservators, you know, some food preservators, okay, some food preservators, these are also made by chemicals. So food preservators, food preservators What is the definition of food preservatives? These chemicals are used to keep the food for long time without destroying. So now, best food preservative, sodium benzoate, sodium benzoate, and its structure. This is the best food preservator. So these are the some importances. Okay, these are the some importance. So many importances are there, but these are the some importances. So very important. So first one, biological purpose. We discussed about nitric oxide and life-saving drugs. So these are very important. Life-saving drugs, very important. Cisplatin and Taxol and agility, and agricultural industry, and insecticides, pesticides. Best insecticide is DDT, and food preservators. So these are some importances. Understood? So now what is the next topic? Matter. 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 So what is the definition of matter? Anything that has some mass and has some space or volume, some space or volume, some space or volume. So that is called matter. That is called matter. So anything that has some, or that occupies some mass and has some space is called matter. So matter we can classified as classified according to two types. So matter can be classified as chemically, as physically. So as physically, matter classified physically as liquids, solids, and gases. And matter classified chemically two types. They are mixers, pure substances, pure substances. Now mixers again two types. Homogeneous mixers and heterogeneous mixers. Homogeneous mixers, heterogeneous mixers. So this is the classification of matter. Matter physically classified as liquid, solids, gases. Chemically classified as mixers, pure substances. Again mixers classified as homogeneous, heterogeneous. Now that physical classification we know well, liquids, solids, gases. So now gases, they don't have definite shape and definite volume. Solids, they have definite shape and definite volume. Liquids, they have definite volume but indefinite shape. Now we will discuss chemical classification. So mixers and pure substances. Mixers. First one, homogeneous mixers. Homogeneous mixers. So what is the definition of homogeneous mixtures? If solute particles if solute particles uniformly distributed uniformly distributed throughout the uniformly distributed throughout the solvent, then that mixture is called homogeneous mixture. Homogeneous mixture. That mixture is called homogeneous mixture. And another definition. So what is the homogeneous mixture? If solute particles uniformly distributed throughout the solvent, that mixture is called homogeneous mixture. So another definition, by using physical methods, physical methods means hand pickling, filtration, like methods. So by using physical methods, if we could not separate, okay, by using physical methods, if we could not separate solute from solvent, then that mixture is called homogeneous mixture. Homogeneous mixture. So if we could not separate solute from solvent by using physical methods, then that mixture is called homogeneous mixture. So we cannot separate easily solute from solvent. So the best example, sugar solution. Example, sucrose water, C12 H22 O11 plus H2O. Sucrose plus water. Sucrose solution. This is homogeneous. Next one, salt solution. So example, sodium chloride plus water, salt solution. Next one, alcoholic solution. Okay, alcoholic solution. Best example, ethyl alcohol plus water. Alcoholic solution. These are all homogeneous mixtures. Now coming to heterogeneous mixtures. Heterogeneous mixtures. What is the definition? If solute particles not uniformly distributed throughout the solvent, then that mixture is called heterogeneous mixture. heterogeneous mixture. Then that mixture is called heterogeneous mixture. If solute particles not uniformly distributed throughout the solvent, then that mixture is called heterogeneous mixture. Another definition, by using physical methods. By using physical methods. So by using physical methods, we can separate. Okay, we can separate solute from solvent. Solute from solvent. Solute from solvent. Okay. So by using physical methods, we can separate solute from solvent. We can separate solute from solvent. We can separate solute from solvent. So example, sand water. Example, sand water. Here we can separate sand from water by using filtration method. And next example, milk. So actually milk is heterogeneous mixture. Milk is heterogeneous mixture. So how it is appeared physically? It appeared as homogeneous milk, but it appeared as homogeneous, but it is heterogeneous. Milk is heterogeneous. How? By using churning process, we can separate foam and water. Means two different layers. We can get two different layers. If we use churning process, then we will get two different layers. One is foam, another one liquid. That's why we can consider it as heterogeneous mixture. So these are the mixtures. Next classification, pure substances. Next classification, pure substances. Pure substances. So pure substances, it is two types. What is that? Elements. Okay, pure substances. Actually here, coming to here, classification, pure substances, again it is two types. What is that? Elements, compounds or molecules. So pure substances, again it is two types, elements, compounds or molecules. Now pure substances, first one, elements. If all atoms belongs to one compound, that is known as element. In element, all atoms should be identical. So elements, they are in pure state. So best example, diamond, graphite. These are considered as elements because these are made up of only one type of element, that is carbon. So that's why these are elements. Okay, diamond, graphite, they are under example of elements, and these are also called allotropes. So allotropes of carbon. So these are in pure state. Now second one, compounds are molecules. If atoms are in pure state, then compound also pure state, because when atoms combined together, then molecule or compound is formed. For example, H2O. H2O, it is made up of oxygen and two hydrogen atoms. Hydrogen, oxygen, hydrogen. So atoms, they are in pure state. That's why compound, it is also in pure state. For example, methane. This is compound. It is in pure state. So it is we can represent like here. So this is carbon. So these are the hydrogens. So if elements or atoms are in pure state and a compound also pure state. So these are the classification under pure substances. It is two types elements, compounds. So elements to compounds, they are in pure state. Now we discussed the importance of chemistry and matter definition and classification of matter also completed. Now next one, base physical quantities. Base physical quantities. Okay, base physical quantities. Base physical quantities. Base physical quantities. There are 7 base physical quantities. So these are very, very important. These are very, very important. So these 7 base physical quantities widely using in chemistry. So these are the 7 base physical quantities. So length, mass, time, electric current, thermodynamic temperature, amount of substance, luminous intensity. So their symbols, length L, mass M, time small t, electric current capital I or small I, and thermodynamic temperature capital T, amount of substance N, luminous intensity IV. And these SI units, length meter, mass kilogram, time second, electric current ampere, thermodynamic temperature Kelvin, amount of substance mole, and luminous intensity candela. So here these are very, very important. Amount of substance very, very important, and luminous intensity very, very important, and remaining also very, very important. These two very, very important. Amount of substance. The SI unit of amount of substance, that is mole. So these are the base physical quantities, and these are important for NEET and JEE main. Sometimes asking what is the SI unit of amount of substance, what is SI unit of luminous intensity, like asking. Okay, so these are the concepts today we discussed. Okay, I hope everyone understood these topics. So we will meet with another lecture, lecture 2. In that lecture, we will discuss uncertainty in measurements and significant figures, and how to round off significant figures to considerable significant figures, and applications. So addition and subtraction and multiplication and division. So we will discuss that lecture in the next session. Okay, thank you so much.